My name is Janus. I'm an electrical engineer. I work for a big power utility company. Well, I designed information systems, from the hardware, designing it, how the devices connect and talk to one another, and then how the end user uses the data. And so that's pretty much and it's taken about 20, 25 years to build that knowledge. What I do now is sort of a scaled down version of that. When I was younger, I always had ideas. And this book is not a technical book, but it sort of outlines the creative processes that were in my brain. So I kind of started off an artist. I didn't really start off an engineer. And drawing and really movies, creative things were really my passion. But then I realized I wanted to do something. I wanted to contribute. I wanted to say something to the world. I like this. This is kind of really cool instrument here.
What is it?
This is a butane soldering iron. This chip right here is based on a Kickstarter program where they take this device here, which is called the Arduino. They take another device called the Raspberry Pi, they combine those two, and they shrink it the size of a postage stamp. And this right here is a micro Linux computer. The cool thing about this is it comes with its own web server. So the idea was to take Legos, which is really good for quick prototyping, and I put this LED, which is actually a really smart LED that I bought from Adafruit. And that LED is communicating with that device into a really local portable server that you can literally put in your pocket and take with you. Design is really important because engineering can be really expensive. Design concepts are really about sitting down in a room and coming up with as many different ideas in as many different ways as you can in your brain and writing it down. And that saves tons of money. And you couple that with research and you can come up with amazing things with fractions of a dollar.
What's electrical engineering as compared to, say, computer science?
Well, electrical engineering incorporates computer science, mechanical engineering, structural engineering. It incorporates material sciences. Electrical engineering just gathers all the disciplines from physics, mathematics. I'm basically a mathematician that has practical experience about the world. And by having and knowing every little things about the world, I can answer questions that are hard to find.
Cool.
And I found that my only avenue was to get a degree in engineering. Originally, I was just going to play basketball, but then someone offered me a scholarship. And I took it in engineering. I wasn't going to do anything else.
Nice.
It turns out that's a good way to communicate to the world using skills.
Cool.
I started off really kind of an artist. I grew up in an artist family. And so it doesn't matter if you get involved with technology from an art standpoint or if you start off being technically savvy. It's really about just getting started. And along the way, there was always tools and things in the garage. There's always things around the house that you can use. It doesn't have to be very fancy. Sometimes I go to the Goodwill and I do harvesting that way. I look for things that are already built and then I just use that. I consider myself a little of both. I mean, I'm mostly a designer if we were to go that route. But I'd like to say on this side of the brain, I'm an artist. On this side of the brain, I'm an engineer. And then when they come together, it's design. I struggled with everything. In fact, in high school, I graduated with a D average. And luckily, when I was going to school, I had someone who saw potential in me. And there were special programs for me to get into college. And I took those programs. And I did a lot of my high school education in college, which made it expensive, but it was worth it. So one concept that I have is you can do anything you put your mind to and don't give up. The good news is that each one of these technologies build on the same underlying infrastructure, the same language, the same operating system, so all the work is not in vain.
So where are we going? Where do you think this tech that you work with, how's it going to change the world in 5-10 years?
Yeah, so I believe just based on my visibility of the industry, there's this new industry coming out, it's called Industry 4.0, where we have a tremendous amount of sensory information. We have wearables. They're pieces of information that we carry with us so we can have a healthier life. We have devices that are going into everything that tells us something about us. It tells us something about how we're using energy, and it's coming. And so, as part of that initiative, I want to be able to understand that and help to bring Industry 4.0 into reality. Some of us are, well, at least for me, I didn't grow up being a good communicator. And often I felt like, I was kind of alone on this island. And if you were consider that being me, I believe that, at least for me, I had a message. I had something that I want to share with the world, whether it was an idea or whether it was something. And it could often feel like, and that's a bottle, it can often feel like the message in a bottle. So today, technology allows us to send this message out to the world. And today, it could look in the form of this, which is called code. And to me, that symbolizes, number one, it's a code that says, here's a bottle of information, and we can use coding to broadcast something to the world, and that's what communication technology does for us, so that we can share ourselves or something about us, our identity, what we think, ideas.
So software is just a platform to reach the world.
It's a platform
And
to
hardware.
reach the world.